Paul McWhorter has started a new series of tutorials. This series involves the Raspberry Pi Pico using MicroPython. Lesson 1 was an introduction. It covered the setup and how to turn on and off the onboard LED with a MicroPython program. In Lesson 2, he set up an externally connected LED and used MicroPython to turn that LED on and off. He asked the viewers to write a program to repeatedly display SOS messages in Morse code. He also requested that the Morse code should adhere to the Morse code timing standards. In this video, I will show my solution to the problem. I'm using a breadboard that I had used on another project. And when I decided to use that, I already had some items on there that I decided to leave. You notice on the lower right here, I have the plus 5 volts from the Pico connected to the positive rail. I have the ground pin connected to the ground rail. And then over here on the left, I have those two rails jumpered to the upper two rails. I also left in place a button. Notice that one side of the button is connected to ground. The other side you can't see, but it's connected to physical pin 34. And if you press the button, that will ground that pin out and cause a reset on the Pico. Now for the homework assignment, I have the plus side of the LED connected to GPIO pin 15 on the Pico. That's physical pin 20. And then on the negative side of the LED, I have a 220 ohm resistor connected to this column, and that column has a jumper to the ground rail. So that is all there is for setting up physically this board. This is the code for sending out SOS messages repeatedly on the Raspberry Pi Pico using the red LED. The first two lines I import a couple libraries, one from Machine to allow us to talk to the pins. This next one allows us to put delays in the program. And then I've defined the red LED as connected to GPIO pin 15, and that is an output from that pin. Now I have some comments that I retrieved from the website that I have shown in the first comment line. And what I got from that site is a DIT. They use the term unit. A DIT is 1 unit. That's the shortest amount of time. A DAW is 3 of those. The time between DITs and DAWs is 1 unit. The time between characters is 3 units. And the time between words is 7 units. Now I've defined 1 unit as 1/10 of a second. Of course, this could be anything you want, but if you make it much smaller than that, it's hard to differentiate the DITs and the DAWs at that speed. So a DIT is 1 unit, a DAW is 3 times that, a character space is 3 times 1 unit, a word space is 7 times 1 unit. Now, both the S and the O's are 3 DITs or DAWs. The S is 3 DITs, and so I have a while loop here that I run through 3 times. I set up a counter of 0. I then turn on the LED, pause for 1/10 of a second, turn it off, pause for another 1/10 of a second, increment a counter, and if it's still less than 3, I do it again. So I'll go through this 3 times. When I'm all done, I want to do a character space. Well, I've already done 1 DIT, so I want to subtract 1 dit from the time between characters. And then for the O, it's essentially a repeat of that, except the timing reflects that we're doing DAWs instead of dits. And in the main loop, we do an S, an O, and an S. We sleep for the word space minus the 2 pauses that we've already done. And we just repeat this over and over again. So we do an SOS, pause, SOS, pause, SOS, pause. Now if we look at the result of that, you'll notice that I have the board set up as I did in a previous picture. And here I'll press the reset button, and when I do, the program will start. Since I've named it main, whenever a program is named main, it starts. So you'll see that it's doing the S, the O, and the S. S, O, S. Okay, there we go. S, O, S. S, O, S.